Yes, good morning, my dear children. Have you all read the textbook in the page number 35 to page number 40? Have you all gone through the pages in the textbook from
Yes,
page
sir.
number 35 to 40? In the previous class, I have assigned that work. Have you read all of you?
Yes, sir.
Only Mahima replied, yes, sir. What
Sir, I
about
read.
the children?
Yes, sir.
Yes, my dear Bibina, you also? Very good. Yes. What about Anmoldeep? Have you read? Yes, very good. Very good. Very good. Inculcate the habit of reading textbook. It is a main resource material for you to improve your knowledge, to get the knowledge, to understand the subject. Inculcate the habit of reading textbook. Don't ignore reading the textbook. Okay, my dear Bibina, Sridarshan, down your hands. It's okay, down your hands. Yes. Eileen, Vargesh, have you read the textbook in the page number 35 to 40? Have you read it? Have you read the pages in the textbook? My dear Eileen, Vargesh, why didn't you read these pages? Please read it. Okay, please read it. Yes. Now come to this point, exercise 2.3. This entire exercise is based on remainder theorem. In the previous class, we have discussed the statement of remainder theorem. If p of x is a polynomial of degree greater than or equal to 1, okay, it is a polynomial in x, and degree of the polynomial is greater than or equal to 1. Let a be any real number. Let a be any constant, any real number. We have taken these two concepts, polynomial and a constant. If p of x is divisible by the linear polynomial x minus a, please remember this expression, my children. In this expression, what is the first term? Tell me. In this expression, tell me what is the first term. How many terms are there in this expression? How many terms are there in this polynomial?
Two terms.
Very good, Sridarshan. Very good observation. Okay, how many terms? Two terms. All of you listen carefully, my dear children. Pay attention here. Okay, don't think, sir did not ask me particularly. Don't think like that. Okay, if I'm asking any question, then that question to all of you, not only a particular student. Okay, so in this expression or in this polynomial, two terms are there. What is the first term? Tell me. What is the first
The X term.
x term? What is the first term here? X term. What is the second term?
The
Constant term.
constant term.
Very good. Constant term. Only two terms are there. So it is a linear polynomial. What is the degree of this polynomial?
So
What is
one.
that? Yes, 1 degree of the polynomial, the highest power of x, highest exponent of x in this polynomial. Highest exponent of x in this polynomial is 1. That is why this is called a linear polynomial. So in this polynomial, if we observe, there are only two terms, especially the first term should be x. Please remember this point. X, first term should be x, not any term, x only letter x, and the second term is a constant. Okay, so then the remainder is p of a. I have explained by an example. If you divide a polynomial, see here I have divided a polynomial x square plus 2x plus 3 by x plus 1. We got here remainder 2. Again, I have divided this polynomial by this linear polynomial. What you got here, remainder, in this second example, we got remainder 0. Yes or no? So this is a lengthy process. This is a lengthy process to find only remainder. If you are giving importance to finding remainder only, when you divide a polynomial by a linear polynomial and you don't give importance to quotient, you are not giving importance to quotient, only remainder. In that case, we use the remainder theorem. By using the remainder theorem, you can find remainder easily without doing all these lengthy steps, all these long division. Okay, my dear children. Now let us discuss this theorem, remainder theorem. How to apply this remainder theorem for the given polynomials. Okay, my dear children. Just I will recall the 2 points. 1 point, if p of x is a polynomial, suppose if p of x is a polynomial, and a is any real number, a is any real number, a is any real number, then what does this notation denote? Tell me. Can you tell me? What is the meaning of P of A? What does the notation, what does this notation P of A denote? Tell me.
Sir, the value of the polynomial p of x where x is equal to a.
Very good, Bibina. Thank you for your memory power. So, in the previous exercise, we have discussed this notation gives the meaning of the value of the polynomial p of x when x is equal to a. Now, come to this next exercise 2.3 for the same notation. First meaning of this notation is the value of p of x, that is the value of the polynomial p of x when x is equal to a. This is one meaning. Another meaning is remainder. P of a denotes, see here, see this sentence, the remainder is P of a. So here P of a denotes the remainder. The remainder when P of x, the polynomial P of x is divided by a linear polynomial x minus a. By a linear polynomial x minus a. For the same notation, there are two meanings. According to the context, you have to take that meaning. Okay. P of a denotes, in one context, is the value of the polynomial p of x when x is equal to a. Similarly, for the same notation p of a, in this context, we say that it is a remainder. It is a remainder when the polynomial p of x is divided by the linear polynomial x minus a. See this magic, my dear children. For the same notation, we are giving two different meanings. So according to our context, we have to take the meaning. Understood this point, my dear children? For the same context, okay, my dear children, for the same notation, for the same word in English also you can take different meanings. What is meant by a mouse? Mouse means rat. Yes or no? In one context, we take it as a rat, animal, mouse. In the another context, if you take in the technical word, mouse means to move the cursor in a laptop or in a system. We use that device, that is mouse. Yes or no? Two different meanings are there. For the same word, mouse, there are two different meanings. Yes or no? Similarly, here P of A has two different meanings. One meaning is the value of P of X when X is equal to A, the value of the polynomial P of X when X is equal to A. And the another meaning is P of A denotes the remainder. P of A denotes the remainder when the polynomial P of X is divided by X minus A. Now, in this exercise, we take this second meaning. Understood this point, my children? We take this second meaning. Now, come to this question. How to find the remainder? How to find the remainder when a polynomial is divided by another linear polynomial? Let us take the same example as we have taken in the previous. See, what is the polynomial divide? Find the remainder. I will write here a sentence. Find the remainder when x square plus 2x plus 3. Find the remainder. For the same question, I am writing here. Find the remainder. Find the remainder when x square plus 2x plus 3 is divided by x square plus 2x plus 3 is divided by x plus 1. X plus 1. So here, for which point we are giving more importance? Only for the remainder. We are giving only importance to find the remainder, not for quotient. We are not interested to find quotient. Only we are interested to find the remainder when this polynomial is divided by this linear polynomial. Okay, first, please remember these steps, my children. Listen carefully. Step 1. First, let us write the given polynomial. It is not given. Let P of X is equal to x square plus 2x plus 3. This is the given polynomial. So we have given, for our convenient, name of the polynomial by P of X. This is the notation. To denote this polynomial, just we have used this notation. P of X is a polynomial. How the polynomial is defined here? X square plus 2x plus 3. This is the first step. They will not give P of X. Okay. Okay, my children, this step 1. Understood this step 1? Now step 2. By which polynomial you are dividing this polynomial? By which linear polynomial you are dividing this polynomial? Tell me. What is divisor? Yes, here x plus 1. So identify that one, divisor. Divisor is x plus 1. Okay. Divisor is x plus 1. This is a linear polynomial. This is a linear polynomial. This remainder theorem we are applying only for linear polynomial. Divisor should be linear polynomial. We study in higher classes for the remaining polynomials also. Quadratic polynomial, cubic polynomial. If you divide a polynomial by a quadratic polynomial, what is the remainder? If you divide a polynomial by a cubic polynomial, then what is the remainder? We extend the same concept for the remaining polynomials also. But we are stopping this concept for linear polynomials only. We are not going beyond this polynomials. Okay. So this is a given linear polynomial. So in this step 2, we have found what is the divisor. Okay. Step 3, after finding the divisor, take that divisor as it is. Take that divisor as it is. What is the divisor here? X plus 1. Now you have to write an equation like this. Divisor is equal to 0. You have to write this equation. Step 3. In step 3, you have to write this equation. Please listen these steps, my dear children, carefully, and remember these steps carefully. In this step 3, what we have done, we have taken the divisor, whatever the divisor is given, and we have written is equal to 0. They will not give this equation. If you observe this equation, this is a simple equation in X. This is a simple equation in X. Yes or no? Is it a simple equation in X or not?
Yes, sir.
Yes,
We
sir.
have, yes, we have created a simple equation for X in the variable X. Now let us solve this equation. Let us solve this equation. Solving the equation means we have to find the value of X. Solving the equation means, what is the meaning of solving an equation? We have to find the value of the variable involved in this equation. So what is the variable involved here? X. Means we are finding the value of X. How do you find here?
Sir,
What is
X is equal to -1.
Very good. We have to transpose constant term. First and foremost step is, while you are solving an equation, please remember this point, my children. First and foremost step is we have to transpose constant term only. We don't disturb X term. We don't disturb the variable term. We write variable term as it is, but we transpose constant term to RHS. Here +1 is there. If you transpose to RHS, it becomes -1. We write this number as it is. Whatever the number in RHS, we write that number as it is. Understood this step, my dear children? Then X is equal to -1. What is the value you got here? What is the value you got here?
So -1.
Yes, X value is -1. This is important number. This number is important. Yes, -1 is important to find the remainder. This number is important. They will not give this number directly. This number is not given directly. We have found X value. By using these 3 steps, we have found X value. After finding this value, X, substitute this value in the given polynomial. Substitute the value of X in the given polynomial. Okay. To get the remainder, to get step 4. Step 4, what should we do? Step 4, to get the remainder, when P of X, that is equal to x square plus 2x plus 3 is divided by x plus 1. We write the same sentence as it is. To get the remainder, write this same sentence as it is in the step 4. To get the remainder, when x square plus 2x plus 3 is divided by x plus 1, put or substitute x is equal to -1 in P of X. Here we are substituting -1 in the given polynomial. We have then get the remainder. Then the remainder that is equal to P of -1. If you are substituting -1 in this polynomial, what will you get in RHS? P of -1 is equal to, tell me what will you get here? What will you get here? Substitute -1 in this polynomial. In the previous exercise, you have done that part. Yes or no? Plus 2 into -1 plus 3. In this step, I have done nothing. Just I substituted -1 in the given polynomial. Understood this step, my dear children?
Understood, sir.
Understood? Anmoldeep, Divina, Sridarshan, Rahul, Samik, Yahuna
Yes, sir.
Singh, Mahima, Tushar, Ben Johnson, Jesslyn, Janet. Yes. Send me message. Yes, sir. Yes, sir. Yes, sir. That's all. If you want to repeat these steps, ask me. Please repeat, sir. Please repeat the steps, sir, like this. If you understood, just send me a message. Yes, sir. That is enough to me. That is enough to me. Okay. Now let us simplify each and every term separately. Separately find the values of each and every term. What is the value of -1 whole square? 1, not -1. Don't be confused here, my dear children. -1 whole square value is 1. Plus 2 into -1, what you get? -2. Plus 3. We got to 3 terms here. After simplifying these terms, we got these 3 terms like this. 1 minus 2 plus 3. What will you get? 4 minus 2. 4, 3 plus 1, 4. 4 minus 2. Final what you get here? 2. What is the remainder here? What is the remainder? 2. If you check this remainder with the previous long division. See here, in this long division, what you got here remainder? What is the remainder? You got 2 or not?
Yes, sir.
Yes, sir.
So here also by using the remainder theorem, you also got the same answer. Here also you got the same answer too. So you have to remember these 4 steps, but I have explained this solution by writing step 1, step 2, step 3 like step 4. But in the examination, no need to write step 1 like this, step 2 like this, step 3 like this, step 4. Only for your comfort, only for your convenient to understand this solution easily. Just I splitted the solution into steps: step 1, step 2, step 3, step 4. But you have to remember these 4 steps. In the first step, what should be done? In step 2, what should be done? In step 3, what should be done? Like a formula, like a song, like a song. How do you remember songs? Similarly, step 1, you have to remember. Step 2, what should be done? Step 3, what should be done? Step 4, what should be done? By following these 4 steps, in the same order, you get the remainder. Okay, my dear children, understood this example?
Understood, sir.
Yes, sir.
Let us take the same example, whatever we have done in the long division. Let us check. I think this example asked Mahima or some other children. Sir, don't we
Sai
get
only
the
asked.
0? Huh?
So Mahima only asked.
Yes. I think Mahima only asked this. Sir,
Yeah, sir.
don't we get 0 as remainder? So here, see this in this long division, we got remainder 0. Let us check the same example by using remainder theorem. Okay, my children, here we have used long division to find the remainder. But in this long division, the advantage is we can find quotient as well as in the remainder. The advantage, the plus points in this long division is we get quotient as well as in the remainder. But by using the remainder theorem, you can find only the remainder. We cannot find quotient. Understood this point, my dear children? To get
Understood, sir.
the quotient and remainder as well, in the shortcut method, we use Horner's synthetic division. In the last class, I told you, I will explain this concept in the foundation class, not in the regular class. By using this Horner's synthetic division, you can easily find out quotient as well as in the as well as remainder. Simply in the simple steps you can find quotient as well as remainder. Okay, in this long division these are advantages, plus points, whereas using the remainder theorem you can find only the remainder, you cannot find quotient. Okay, now let us take second example. Let us take the second example. The same example, I am taking the same example. Find the remainder. Find the remainder. Find the remainder when. Find the remainder when. I am taking the same example, my children. When x square plus 5x plus 6, x square plus 5x plus 6 is divided by x plus 2. What is the divisor here? X plus 2. Okay, we are dividing this polynomial by x plus 2, a linear polynomial. Now we are giving more importance to find the remainder only. We are not interested to find quotient. Please remember this point, my children. Here we are interested in finding the remainder when we are dividing this polynomial by a linear polynomial. Please remember this point. So what is the step 1? Tell me. What is the step 1? I will show you what is the first step. See here. What is the first step here?
So let P of X be.
Yes, very good. Let P of X is equal to. What is P of X here?
So X square plus 5X.
Let P of X is equal to x square plus
5X plus 6.
5x plus 6. Here it is not given. We assumed here. For our convenient, we assumed here. This is not given in the question. P of X is equal to x square plus 5x plus 6. Like this, they did not give. Only for our convenient, we assumed given polynomial is P of X. Okay. Now, what is step 2? What is step 2? See here. What is step 2?
The divisor.
What is the divisor here? Tell me, what is the divisor?
Plus 2.
Divisor.
X plus 2.
Yes, very good. X plus 2. This is a divisor. Now come to step 3. What is the step 3? Tell me what is step 3 here?
So X plus 1 is equal to 0.
Then what should we do here in this step 3?
Plus 2 is equal to 0.
Yes, divisor, whatever the divisor we have found, whatever the divisor we have identified here, write it as it is, write that divisor as it is. Okay, is equal to 0, put here is equal to 0. Then you get an equation, a simple equation in the variable. Now we have to solve this equation. Then what is the value of x here? X is equal to 0 minus 2. Very good, Srijana. Very good, Amma. X is equal to minus 2. So in this step 3, we got x value, that is minus 2. Now come to step 4. What is the step 4? So after finding the value of x by solving the equation, what I wrote here, to get the remainder, when I wrote the question as it is, just in the place of find, in the place of the word find, just I wrote to get the remainder, when x square plus n or p of x, when p of x is equal to x square plus 5x plus 6 is divided by x plus 2. What I wrote here, substitute Substitute x is equal to minus 2. Here we got x is equal to minus 2. Okay, my children. Substitute x is equal to minus 2 in P of x. In P of x, then the remainder, then the remainder, see here. Remember these steps, my dear children. Then the remainder is equal to P of, what should be done here? What should be written here?
-2, sir.
Very good, my dear Shanti. Very good, Amma. P of minus 2. What is meant by P of minus 2?
The value of x.
The value of P of
So
x.
the value of P of x.
Previously also I told the meaning. The value of P of x when x is equal to A. Yes or no? We use that meaning here. P of minus 2 means the value of P of x when x is equal to minus 2. So what will you get here? Minus 2 whole square plus 5 into minus 2 plus 6. In this polynomial, there are 3 terms. We substituted x is equal to minus 2 in these 3 terms. Now, let us simplify each and every term separately. What is the value of minus 2 whole square? What is the value of minus 2 whole square? No, man, no. The value of x may be positive. The value of x may be positive. It may be a rational number. It may be a rational number. Okay, Mahima. Mahima asked a question. Very good question. Mahima asked a very good question. Sir, in all cases, the value of x will be negative. Not at all. The value of x may be positive number, it may be negative number, it may be a rational number. 2 by 3, x is equal to 2 by 3. Like this we can get, or x is equal to minus 1 by 2. Like this also you can get. Okay, my dear Mahima, we can get the value of x. It may be positive integer, it may be a negative integer, it may be a positive rational number, it may be a negative rational number. Understood this point, my dear Mahima? Understood this point?
Understood, sir.
Yes. Understood, my dear children? Please, she asked a good question. All of you listen carefully again. She asked here, sir, shall we get the value of x always negative integer? Not at all. We can get the value of x. It may be a positive integer. It may be a negative integer. It may be a positive rational number like this. I wrote here in rough 2 by 3. It may be a negative rational number, minus 1 by 2. Like this also we can get. Okay. Whole square. What is the value of minus 2 whole square? Tell me. Tell me fast.
4.
Yes, very good, Sri Darshan. Very good. 4. Very good, Srujanamma. What is the second term? Tell me. Tell me fast.
Minus 10.
Very good.
-10.
What is third term? We write 6 as that is a constant term. No need to simplify third term. We write this third term as it is. Tell me 6 plus 4. These are positive numbers. What will you get? Plus
So plus
10, sir.
10 minus 10. What is the
0.
10 minus 10? What is the value? So
0.
what is the remainder here we got?
0.
In the previous method, means in the long division, what you got here remainder? In
0.
the long division, here also you got 0. When you divided this polynomial by x plus 2 by using long division, here also you got a remainder 0. Yes or no? In both cases, you got the same answer. Understood this point, my children?
Yes, sir.
So the just a small difference between this long division and remainder theorem is, in this long division, I told you clearly 2 advantages. The first advantage is you can find quotient also as well as remainder. Whereas in the case of applying remainder theorem, if you use remainder theorem, then we get only the remainder. We cannot find quotient. We can get only the remainder. We cannot find quotient when a polynomial is divided by a linear polynomial. Understood this point, my dear children? Understood this point?
Yes, sir.
So, come to the exercise 2.3. All of you open the textbook. All of you open the textbook at page number 40. All of you open the textbook at page number 40. All of you be ready fast, my dear children. Hurry up. See page number 40. In this 40, there is exercise 2.3. This entire exercise is based on finding remainder when a polynomial is divided by a linear polynomial. See the first question. Find the remainder when x square, x cube plus 3x square plus 2x plus 1 is divided by, here different parts are there. Here different parts are there. How many parts are there in this question? Tell me.
So 5.
Total 5 parts are there. Here I am explaining first, second and fifth one. Please try the remaining questions. Second and it's okay, ma'am. It's okay. I'm writing the question here. Don't worry. Sridarshan, it's okay. Don't worry, my dear Sridarshan. I'm writing the question here. Okay. But please try the remaining questions. Here in this class, I'm explaining the question number 2 first. Okay. Find the remainder. There are 5 parts in this question. I'm explaining here second part. Okay, find the remainder when x cube, what is the polynomial? Read that polynomial, my dear children. X cube
Plus 3x square
plus 3x square
plus 1.
plus
1.
after 3x square. See
So
that
one.
polynomial carefully, Mahima. X cube
3x
plus
is
3x.
there.
3x, you missed that term.
Yeah, sir.
Is divided by x minus 1 by 2. X minus 1 by 2. We have to find the remainder when this polynomial is divided by x minus 1 by 2. If you observe, this is also a linear polynomial. What is the step 1? Tell me. For every part in this question, follow the same 4 steps. Polynomial may be different. Value of x may be different from question to question. Okay, my dear children. Let what is the first step? Let p of x is equal to x cube plus 3x square plus 3x plus 1. This is the first step. What is step 2? What is step 2?
The divisor.
In the step 2, you have to identify the divisor. What is the divisor here? Tell me.
X minus 1 by 2.
Very good. Very good. My dear Shanti, x minus 1 by 2. In step 3, what should be done here? What should be done here in step 3? Write this divisor as it is. Write this divisor as it is. That is x minus 1 by 2. Is equal 0. We have to keep is equal sign and 0 also. We have to create this equation. In step 3, previous example also see, my dear children. Step 3, we wrote this divisor as it is and kept here is equal sign and we wrote 0. Then you get a simple equation in x. This implies what will you get here? This is a constant term. You have to transpose. Then x is equal to 0 plus 1 by 2. Yes or no? Understood this, sir?
Understood, sir.
Step 3. Understood this is step 3, my dear children.
Understood, sir.
Yes, sir.
Understood, sir.
X minus 1 by 2 is equal to 0. This is important step. They have not given. You have to create this equation to find the remainder. This step is important. So we found x value. What is the value of x here? What is the value of x here?
1 by 2.
Sir, 1 by 2, sir.
1 by 2. So what should be done in step 4? What should be done
Sir,
here?
we must substitute 1 by 2 in the place of x.
Yes, to get the remainder, I'm writing the same steps here, my children. To get the remainder, when p of x, that is equal to x cube plus 3x square plus 3x plus 1 is divided by x minus 1 by 2. Substitute x is equal to 1 by 2 in p of x. Then the remainder. What is the remainder? Tell me. Then the remainder is equal to. How do you denote remainder? How do you denote remainder? Previously also I told you there are two meanings. Remainder, P of A. Okay. P of A means what is the value of x here? 1 by 2. So P of 1 by 2. Now tell me P of 1 by 2. Tell me P of 1 by 2. Past. What is the meaning of P of 1 by 2?
So 1 by 2 the whole cube
1 by
plus 3 into
Yes.
1 by 2 the whole
The value-
square.
Yes, the value of this polynomial when x is equal to 1 by 2. So 1 by 2 whole cube plus 3 into 1 by 2 whole square plus 3 into 1 by 3 plus 1. Now 1, 2, 3, 4. 4 terms are there. 4 terms are there. Out of these 4 terms, last one is constant term. So no need to simplify this last term, constant term. But you have to simplify these first 3 terms. 1 by 3 whole cube. Sorry, 1 by 2 whole cube.
Sir.
What will you get? 1 by 2 whole cube. What will you get? 1 by 2 whole cube. What is the value of 1
So
by 2
1 by
whole cube?
8.
1 by 8 plus 3 into
So
what is the
3
value
by
of
4.
Yes, very good. 3 by 4 plus what will you get here?
3 by 2.
3 by 2 plus 1.
1.
Understood this step, my children? Now take LCM. Now take LCM for the denominators because all are fractions. So let us take the LCM for the denominators. 2, 4, 8. For all these 3 numbers, LCM is 8. 8 1 times. 4 2 times. Please listen carefully, my children. 4 table here. 2 times goes in 8. So 2 3s are 6 plus 2 table goes in 8 for 4 times. 4 3s are 12 plus here there is no denominator, means we have to consider as 1. So 1 8, 8 ones are 8. Understood this numerator, my dear children? Understood this numerator? What, my dear Sujna? 3 into 1 by 2. What will you get? 3 by 2 only. Understood? Now, understood this numerator? Now simplify these 4 numbers in the numerator. 12 plus 8, 20, 27. 27 by 8. This number is said to be the remainder. This number 27 by 8 is a remainder when the polynomial is divided by x minus 1 by 2. Okay, my children?
Yes.
Will you do the remaining parts of this question number 1?
Yes, sir.
Will you do the second question also in this exercise? Will you do the remaining questions in this first Roman as well as second Roman also? Will you do these 2 questions
So
as
in
homework?
first question, it's given x plus pi.
What, my dear?
So in fourth question, it's given as x plus 5. Can you do that?
Follow the same steps, Amma. Follow the same steps.
Sir, we need to substitute the value of pi.
Pi only.
So the
No,
pi
just
also we should substitute.
pi only, that's all.
Sir,
is
our pi we must keep it like that itself. With pi symbol itself we can keep, or we must substitute the value of pi.
No need to substitute the value of pi. Keep that symbol as it is, pi. Substitute the pi as it is. No need to write the value of pi, 22 by 7 or 3.141. Okay. 3.414 like this. No need to substitute the value of pi in this case. Okay, my dear children?
Okay, sir.
Right. Do that questions as homework and substitute, submit your work, okay, in the classroom. Now the time is 9:49. You can leave the meeting, my dear children. Take rest, take care
Thank
of
you,
your
sir.
health, my dear children. Stay at home, stay safe, sanitize your hands frequently. What, my dear Anmol?
Thank you, sir.
Okay, left. Thank you all, my dear children, and do
Thank
your
you,
work
sir.
sincerely. Do your work sincerely, and okay, my dear Mahima, thank you. Do your work sincerely and seriously, and submit your homework sums in the classroom. Okay, my dear. Okay, my dear children. Yes, thank you. Bye, Mahima. Bye, Ma. Thank you, Ma. Shanti. Thank you. What, my dear? Trinson, what's your doubt? Tell me. What's your
Sir, I had network issue, so I joined only half class. Just now only I joined, sir, because of
no
network
problem.
issues.
No problem. No issue. I will post this video. I post this class in the video format. Okay. Don't worry for missing the class. Don't worry for missing the class. You can watch the video right from the beginning. Okay, my dear Trinson.
Okay, sir.
Watch the video right
Okay,
from
sir.
the beginning.
Thank you, sir.
I recorded this class in the video format. I will post it in the Google Classroom. Please watch that video right from the beginning. No need to worry for missing the class. Okay?
Okay, sir. Thank you, sir.
Okay, thank you, Princeton. Thank you.